Okay, next is polar equations. So if x and y coordinates, there's a relationship between the Cartesian and the polar, and these are what they are. X equals r cos theta and y equals r sin theta. Then you can convert Cartesian equations to polar and vice versa. So let's have a look at what we might do. So converting the following into polar form for polar equations. Okay, there we are. So we might start with something like this, for example. Let's say x squared plus y squared equals 25. So that would be a circle, of course. So look at the polar form of that. So essentially all we do is replace x by the polar form and replace the y by its polar form. So when we do that, we'll have r cos theta squared plus r sin theta squared equals 25. So you get r squared cos squared theta plus r squared sin squared theta, and that equals 25. So r squared, of course, comes out as a common factor, leaving you with cos squared theta plus sin squared theta equals 25. And of course, cos squared theta plus sin squared theta equals 1. So what we have then is r squared equals 25, which then leads us to say that r equals 5. So what that means is that that's any point. So I'll just do a little quick sketch here. That's any point that is 5 from the pole, the origin. Any point anywhere, any point anywhere, any point anywhere, that is 5. So 5 there. So what do you get? You get a circle, because every point on this circle is 5 from our pole. Alright, so that's kind of what that means. Alright, so you can do that for any equation. Say a linear y equals 2x, for example. We can do it for that as well. Okay, so we know that y is r sin theta, so r sin theta is equal to 2r cos theta. The r's will cancel until you have sin theta over cos theta equals 2, and seeing as sin theta over cos theta is tan, yes, so you have tan theta equals 2. So that's any point where tan theta equals 2, and if we then find that theta is tan minus 1 of 2, and it's not an exact value, so we need to get our calculator out to do that. And when we do that on our calculator, we find in degrees and minutes it would be 63 degrees and 26 minutes. So any point where, doesn't matter what the r is, what the radius is, how far from the pole, but at any point that makes that angle is what we are interested in. So any point where there's an angle of 63 degrees and 26 minutes, and that would be any point on that straight line there. That would make that angle. Alright, like so. Okay. Let's have a look at something else then. So say 2x minus 3y equals 5, for example. So again, substituting those things. 2x, that's 2r cos theta minus 3r sine theta equals 5. R's are a common factor there, so I'll take it out. So we've got 2 cos theta minus 3 sine theta equals 5, and so R then would be 5 over 2 cos theta minus 3 sine theta. And divide both sides by that bracket. Alright, so that's what the polar form of that equation looks like. So as you can see already for the first three, sometimes the polar form of the equation is quite simple. Like the first one, R equals 5, and other times, as in this one, the Cartesian looks more friendly. Alright, let's have a look at a couple of others. I'll just have a look at one more. So x squared on 16 plus y squared on 9 equals 1. Hyperbola, for example. So same deal. We've got r cos theta squared on 16 plus r sine theta squared on 9 equals 1. Alright, so when we remove those brackets, r squared cos squared on 16 plus r squared sine squared on 9 is 1. R squared can come out as a common factor, and so then you've got sorry, I need to, got ahead of myself here. We need common denominator first before we can take r out as a factor. So, the easiest thing to get a common denominator is just to cross multiply 9 times 16, so you have 9r squared cos squared plus 16r squared sine squared. And that's on 144, and it's still equal to 1. So if I then my r squared is a common factor, and I've got 9 cos squared theta plus 16 sine squared theta, and I'll times both sides by 144 at the same time, and so then our final equations r squared equals 144 over 9 cos squared theta plus 16 sine squared theta for that particular one. Alright, of course if you can go from Cartesian to polar, you can go from polar to Cartesian, and so let's have a look at some of them. Okay, so let's have a look. R equals 4 cos theta. Alright. Now we need an R we need an r in here, because if we've got r cos theta, we know that that's x. We can't just put an r on there, we're going to put an r on the other side as well. So we've got r squared equals 4r cos theta. Now, r cos theta, that's x, and r squared, that's, of course, x squared plus y squared. So we need to then say that x squared plus y squared equals 4x. Alright, so it's not quite where we need it to be at the moment, so x squared minus 4x, stick them together, plus y squared equals 0. Now, the reason I've left that there is because I need to leave a bit of space here as well, because I'm going to turn this into a perfect square, so x minus 2. So if I'm doing that, then I've got to have another 4 added there, and if I'm going to add 4, keep it balanced, we've got a minus 4. Okay, so plus y squared, and this 4 here, I'm going to put it over the other side, equals 4. So, there's our Cartesian form. X minus 2 all squared plus y squared equals 4, so we recognise that as a circle. Alright, next one. Tan theta equals 2. So, tan theta would be y on x, so we know that y on x equals 2 or y equals 2x. Okay, simple conversion on that one. Alright, last one that we'll look at. R equals 2 over 1 plus sine theta. Okay, let's have a look then. Let's multiply both sides by 1 plus sine theta, get it. Over there, expand that bracket, r plus r sine theta equals 2. Now the r sine theta bit, that bit there of course is y, so we've got r plus y equals 2. And so we've got r then equals 2 minus y. And if we square it, r squared is 2 minus y squared. And the benefit of squaring it is now x squared plus y squared, which is what r, equals 2 minus y. And I'll put that squared in the wrong spot. Hopefully you already noticed that. Squared. Alright, so if we go up over here now, finish it off, we've got x squared plus y squared equals 4 minus 4y plus y squared. Y squareds cancel. And so we have then, when we do a bit of rearrangement, we have x squared minus 4 equals minus 4y. So 4y equals 4 minus x squared. Divide by 4, y equals 1 minus x squared over 4. And there's our final answer. Okay, so a bit of algebraic manipulation. I'm sure you're up to it, I'm sure you can handle it. So that's exercise 10F, set number 6.